Did you know that 20,000 years ago, the area where New York is today was completely covered with ice? So if the Statue of Liberty were back then as it is today, it would have come up to the top of the Statue of Liberty, that ice. If you go a little farther north to the city of Boston, the ice that covered that area would have been several thousand feet above where the city of Boston is today. So we know that back then, of course, that was part of the Ice Age. There was a cycle on our planet of very cold weather known as the Ice Age. Obviously, that ice has dissipated and melted away over the past 20,000 years to what we see today. But there are still things going on in our climate, still cycles that might cause a disruption. In this video, we're going to learn about some of those cycles and some potential issues that we will face with climate change. Let's get started. So in this video, I want to go over several big ideas and topics. What we're going to look at in this video are what we consider to be ecosystem dynamics. The first thing we're going to look at is succession, how different life succeeds other species of life. We're also going to talk about the water cycle and how important that is to our planet. We'll look at the carbon cycle and how important that is to our planet. And then we'll wrap up with a discussion that is very relevant to today, that is climate change. What's going on with our climate? What's causing the climate to change? And what are the factors driving that change? Okay, so the first topic we want to look at is ecological succession. And ecological succession is really just the sequence of changes within a community. So it's really about how the composition of species changes over time. And this might be after a disturbance, for example. So in these pictures that we've got here, there was a fire in the forest. 1 year after the fire, what you see is, right, just some small grass starting to move up. Then another year after the fire, year 2, you'll see even more, maybe some small shrubs starting to form. So when we talk about succession, what we're talking about is the placement and how the sequence of a community changes over time and what species make up that composition over time. So there is a pattern to this we call ecological succession. And this is the succession of a forest, okay? And so what you see here is, let's say there was some disturbance. Maybe there was a fire, some tsunami, something, or something caused by humans. And the earth was taken back to just the soil. Well, or in this case, bare rock. So we start with just some bare rock. Then the first thing we start to see here is some mosses, and then some grasses, and then what we call woody pioneers. These are shrubs, right? They've got a little bit, sort of a thicker stem, a more woody stem. Then you'll see some fast-growing trees, followed finally by the climax forest. And you can see up here as we go through these different successive iterations, different things peak. So early on, right, it was just rock, but then the mosses and the grasses peaked. Then the woody pioneers, the fast-growing trees. Now notice here in our climax forest that we have a lot. We've got quite a bit of diversity, biodiversity in this climax forest, but it took a while to get there. So what I want to do now is I want to break down the two different types of succession. The first one we want to talk about is primary succession. And this begins with virtually lifeless area, right? So no soil even, not even any soil. So basically rock. Okay, so if we start with rock, then the first thing that we finally see, or that we first see, are bacteria, lichens, and mosses. These things here will actually, over time, start to break down, and that will form our soil. So on rock, these lichens and mosses over time will start to form this layer of soil. You can see the soil starting to form here. Here it was all rock. Now we see a thin layer of soil. Once we have soil, we'll get to see other things. So we call these bacteria, lichens, and mosses the pioneer species. They were the pioneers, the first ones there. Then we see the grasses. Those are things that compete well in high sunlight, right? There's no shade really. So what you're getting are things that do well in sun, like grasses. Then we're going to start to see shrubs form, right? Those would be things that are starting to get a little more shade tolerant. And finally, trees that make up our climax forest. So we started with lifeless soil or lifeless rock. We got moss, pioneer species. Those broke down, started forming the soil. As these things die, notice what happens to our soil level. Keeps getting deeper and deeper, richer and richer, so that other larger trees and things can survive. So that's primary succession. Primary starts with no soil, without soil. Secondary succession, the second one we want to talk about then, is when there is a base soil still intact. So we're not starting from rock. There is some soil there to begin with. And we typically see secondary succession start after we've had like a major catastrophe or some catastrophic event like a fire. And here is the general flow of how this would work. All right, so let's say we have we start here with a nice climax community. Everything's going well there. Then there's a fire. That fire, what it does is it wipes out the community, but the other thing that it does is it actually releases nutrients that had been stored in these trees for years, right? So you have all of these nutrients that are stored here within the life itself. What a fire does is it actually restores a lot of that back to the soil. And so that essentially, that disturbance, like a fire, starts the whole process of succession over again. So then here we go. We're starting again with the grasses. And then we move to some shrubs. And then some fast-growing trees. And then finally we get here to our climax forest again. So the big difference between primary succession and secondary is that primary starts with no soil, just bare rock. The soil has to form from the lichens and mosses that break down. Secondary succession means we start with soil. So there's already the base layer that's ready to go in secondary succession. Okay? So, moving on. Let's talk about our planet and what are the inputs into our ecosystems on our planet. Well, obviously, the biggest input we know of is the sun. The sun has a constant input of energy onto our planet. That's consistent, constant. It comes from the sun. We can pretty much rely on that input of energy. That's coming from off our planet, right, onto the planet. The other stuff, the nutrients, we actually have to recycle, right? The water, the carbon dioxide, the nitrogen, all of these things that we need for life have to be recycled because there's not some ship coming on to our planet and bringing new nitrogen, new carbon dioxide, new water, right? These aren't coming from somewhere else. So what's on the earth is what we have. It has to constantly recycle. Now we get a constant input of energy, but the nutrients we have to recycle. So what I want to talk about now are some of those nutrient cycles that we see on our planet. One of the most important, of course, is water. So if you think about the water cycle, let's say we've got some water here in a pond. Well, when the sun comes out, we got some heat, evaporation occurs, that water moves up into the atmosphere. So the process of going from land up into the atmosphere, evaporation. Once that water becomes dense, it condenses into clouds, right? So water that was once in the lake, evaporated, condensed into clouds. Those clouds continue to form, and eventually, when those clouds are ready, that precipitation falls back down. Another side effect is that while some water evaporates directly from a pond or a lake, some water actually transpires through the trees. Do you remember back a few videos ago, we talked about transpiration. And transpiration is when you have a plant, like a tree, for example, that takes water from under the ground, brings it up through its xylem, evaporates that water vapor out of the stomata into the atmosphere. So It can evaporate directly, condense into clouds. It can also transpire and go into the clouds as well. Now, when those clouds are ready, of course, that will fall back down as precipitation, back down to the land, and then some of it will soak into the ground, go below the surface, and then some of it will run off back into lakes, ponds, streams, etc. So the water cycle is very important because, like I said, we have a limited amount. Well, there actually is an issue with the water cycle, which we cause a disruption to this particular ecosystem. And humans are directly impacting this. So breaking the water cycle, a disruption is impacting the homeostasis of our ecosystem. So for example, a major issue is deforestation. So what you see here is some deforestation in Brazil, right? Many people call that the lungs, right? The rainforest, the lungs of our planet. That's maybe a little misleading. We know a lot of our oxygen actually comes from life in the ocean, but still, these rainforests, these areas of forest and in Brazil are really important to our planet and to our ecosystem. So a lot of deforestation is occurring. You can literally see these trees being wiped out, right, for different reasons. And then logging, of course, urbanization, that is more urban sprawl moving out. Invasive species being introduced to a region, taking all the water. These are examples of breaking the water cycle. Now, you may say, how does cutting down these trees break the water cycle? Right? I get the oxygen thing, but how is it breaking the water? Well, do you remember what we just mentioned? Transpiration. What happens is that the plants take water that's in the soil, in the ground, it moves up through the plant into the atmosphere, and then eventually falls back down. So if we're cutting down all the trees, all the plants, that water that's in the ground, that groundwater, will never be able to get back into the atmosphere, so it condense and then rain. So it's messing up our water cycle because we'll have areas that are now going to be more prone to drought because there's just not as much water vapor in the air. So the groundwater that's not transpired into our atmosphere, we don't create precipitation, so it doesn't fall back and we might see some droughts or more easily accessible water. So deforestation is a severe problem on several different fronts. Yes, we're cutting down forests, but we're also, and that's not great, right, for the oxygen that those trees produce, but also we're limiting the amount of water then that can be pulled out of the ground. Okay, so another really important cycle that you're probably hearing a lot about these days is the carbon cycle. So the carbon cycle, when we think carbon cycle, what I really want you to think about is CO2, right? Carbon dioxide. So how does this carbon cycle work? Well, think about a factory, a fossil fuel factory, where burning fossil fuels, that's releasing a lot of carbon dioxide into the atmosphere. Well, other thing that puts a lot of carbon dioxide into the atmosphere is when I drive my car, right? I wish I had a cute little car like that. But if you do and you have a car that's putting out a lot of exhaust, right? How does this car run? Well, gasoline, which is a fossil fuel that you're burning. We know fossils contain a lot of carbon. When you burn them, that carbon, of course, goes right into the atmosphere. So we're putting carbon into the atmosphere, carbon dioxide, by factories, by our transportation. That's how we get it in the atmosphere. Now you may say, well, that's all right, Herder, because I know that plants take carbon dioxide out of the atmosphere. And you'd be right. Carbon dioxide is taken from the atmosphere process of photosynthesis. In the Calvin cycle of photosynthesis, you may remember that the carbon dioxide is taken into by rubisco, the enzyme, and is added to a sugar. So photosynthesis takes out carbon dioxide. Now, we've got plants on land that do that, but as I mentioned earlier, there's actually a lot of plants and a lot of plant-like species in the water that undergo photosynthesis as well to take the carbon dioxide out. All right, so we're putting carbon dioxide in, we're taking some carbon dioxide out. What else is happening? Oh, well, the cows and the pigs that eat the plants. So photosynthesis happened. Those plants worked really hard to take out the carbon dioxide. Well, what do? We eat those things, and then we undergo cellular respiration. We break down those sugars and release that carbon dioxide back into the atmosphere, of course. So we put more back in. Another thing that also happens is what we just call diffusion. So there's some carbon dioxide in the atmosphere. Some of that naturally diffuses into the water, right? Which the plants will need to grow as well. And then some of that carbon dioxide actually just diffuses out of the water back into the atmosphere. So that dissolved CO2 in the water is then used by the plants in the water to undergo photosynthesis as well. Now, what happens at the end of the cycle? These things die. Plants die. Cows, pigs, fish, humans, we all die, things die. That gets back into the ground. Those nutrients are essentially restored to the earth. Now, over time, many generations, those dead things would become fossils, right? What do we do, though? Those fossils that are buried deep within our earth, that are holding all this carbon, we call them carbon sinks, right? They're storing a lot of carbon deep in the earth. Well, we go down, we dig it up, we take it to a factory, we put it in our cars, we burn it. That carbon dioxide is continually being put back in our atmosphere. So this is just the general carbon cycle, how carbon dioxide is cycled through our atmosphere. Now, just like water having an issue, the carbon cycle is causing a pretty big issue on our planet as well. What do I mean? Well, think about Earth's atmosphere. Earth's atmosphere, the thing that protects us from the sun, is really a blanket of gases. It protects the Earth. Well, those gases protect us, but they also are starting to do a little harm. We call some gases greenhouse gases. Water vapor, nitrous oxide, methane, and then one of the big offenders here, carbon dioxide. What's happening? Well, we call these greenhouse gases because think about a greenhouse. Got the sun here. Let's say we wanted to put some plants, but we wanted to keep the plants warm. So we put a glass lid over the plants. What happens to the heat? The heat comes in, and then instead of hitting and evaporating back out or dissipating back out, the heat gets trapped in there, keeping the plants warm. All right, that's a greenhouse. That's how greenhouses work. That's how we grow plants throughout the winter. However, what's happening on our planet is that we're making a greenhouse unintentionally, or maybe intentionally. I hope that we are unintentional in it. And these gases that are really thick are forming a blanket. So here's what's happening. Instead of the heat coming to the surface, bouncing back out, the heat comes to the surface, backs up, hits this blanket of gases, and then falls back down. So the heat doesn't get back off the surface of the earth, and instead is trapped under these gases and continues to warm up the planet. So this is a big issue on our planet with climate change. We can see what we're doing to cause this. So I'm telling you that this is an issue. Let me give you some data to support that. Here's some evidence for climate change. This chart is looking at CO2 concentration over the past 800,000 years. So here we are, thousands of years ago, 800,000. Notice that there's just sort of a general cycle. And we can measure these different ways, taking core samples, et cetera, to see how much CO2. Then if you take, okay, this is sort of a natural cycle. It sort of cycles between 200 to 75. Then if you look at the Industrial Revolution, so take from here, blow it up, here's what we're seeing. From 1,000 years, the year 1,000 to 2,000, notice what gradually happens when the Industrial Revolution starts. The CO2 we're putting into our atmosphere is really starting to take off. So it is getting really high levels. The CO2 level in our atmosphere is now closer to 400, and many people think it's going to go way beyond that if we're not careful. So what's that then doing to our temperature? Well, you can see the global surface temperature of our planet has increased, right, above sort of this mean here, drastically. Close to 2 degrees Fahrenheit, 1.2 degrees Celsius. And people see this and they're like, okay, Herder, 1 or 2 degrees Celsius, is that a big deal? Why is that such an issue? Well, think back to the beginning of the video, the Ice Age. Take a guess. How many degrees cooler do you think the Earth was when we experienced the Ice Age? 20? 30 degrees cooler on average? It was actually just 4 to 6 degrees Celsius cooler. If you look to a chart here that I've pulled up, 20,000 years ago when we had the Ice Age, right? Boston completely covered, New York covered with a sheet of ice, was roughly 4 degrees cooler than the last century, right? There was a gradual warming up. And then for about 10,000 years, we stayed pretty even. So a change in our global temperature of an average of 4 degrees below the average was what caused the Ice Age. New York covered, Boston covered. Are we going back to the Ice Age? Well, no. We're actually going in the other direction. So if you take this little area right here and sort of zoom out, notice what's happening. We are already 1 degree above. So we're up here, right? Think about 4 degrees the other way, what that caused the Ice Age. 4 to 6 degrees this way is going to be catastrophic for our planet. And so that's why so many scientists are concerned about climate change, because the data is showing us that this is a really big issue, okay? So is there any evidence? What's it affecting? A lot of people say, well, how's this impacting me? It's not going to, I'm not going to be here, I'm going to be fine. Well, it is impacting us already today. In 2019, I was lucky enough to get to take a little trip through the summer. We were moving through Spain and Portugal. And when I was there, they were having a record heat wave. And what we're going to see is that we're going to have more of these record heat waves throughout Europe, throughout the Americas, throughout different parts around our country. Those heat waves and the dryness created by them cause these horrible fires. You may remember back to the brush fire in Australia that was so horrible and was wiping out so many species. These things are a direct impact of climate change that's already occurring. Another one you might not think about is insects. You look at this and you're like, well, what's going on with the insects? Well, think about our insect population. The winter, if we have a hard freeze, that kills off a lot of insects in certain areas. And what you see here is with increasing temperatures, the pine beetle population was not reduced enough during the winters because we're having these warmer winters. And what happened is, as you can see, there's a lot of destruction with a lot of forests because some of these pine beetles don't get properly reduced in size in the winter, and then their population just takes off when it warms up, and that's going to destroy a lot of our forests. Also, I think I've told you before, when I had visited Venice, I didn't take this picture, but it was very common. I remember we went in to tour one of these, this great cathedral here, and when you go in, there are planks of wood above the church because the water in Venice is now on the land very often. So you can't even go into some of these buildings anymore without standing on these platforms or on planks because the water is just continuing to rise. So as our sea levels rise, because the warming temperatures melting the glaciers, then we're going to see more and more of this. And of course, the ice melting is causing problems to animals like polar bears who rely on this ice. And then the warming temperature in the north is melting this permafrost, and it's melting all this permafrost, and it's actually releasing a lot of methane, which is just perpetuating the problem into our atmosphere. Droughts in Texas, very common that we're seeing more and more. Cropland, farmland being obliterated by these droughts. And then I mentioned before as well the horrible problem that we see with the Great Barrier Reef, with the coral bleaching because of the change in temperatures and the acidification of the ocean with all that CO2 in the ocean. So I'm leaving you, unfortunately, on a sort of a grim outlook. Things are going on in our climate. Things are changing. We have a lot of impact from climate change and CO2 in our atmosphere. And my generation of people before me have not done a great job. So it's up to you. You're going to have to start making some of the tough choices. You're going to have to be innovative. You're going to have to help solve these problems because, unfortunately, people my generation and older have been ignoring some of this for a long time. So instead of being discouraged, be encouraged. You can make a change. You can make a difference. You can help to solve some of these problems with climate change.